Hello. Who do I got? Aslan, Paul, and Kai. Jack and Alessandra. Welcome. Welcome, welcome. Let me write in. Today is the Monday, and it's the 1st of March. So 1, 3, 2, 1. We met fifth period. Good. I got a bunch of you in here. Okay, good morning. Malta, Matthias, Inessa, Alessia, and Sophie. Wunderbar. Oh, Linus, Stella, Aaron, Tim H, Isaiah, Sina, and Leo. You guys are quick today. 1, 3, 2, 1. Fifth period. Hello, Leo. Yes. Lauren, Ayala, Kiara, Hannah, Corey, Timothy P, Tim H. I got already. Charlotte and Isabella. Put those there. Woo! Who else I got? I got Isaiah. I got you already. Ingrid. I got Corsine. I got Zach. Felix. Good. Okay. And I missed a couple. Do I have Liam yet? Do I have Liam? Do I have Avram? Do I have Ali? Do I have Julius? Do I have Amelie? Do I have Michael? And do I have Clara? A question about distance learning. Fire away. Go ahead, Alessia. I'll check the other class too in a sec. I got now. Clara's here. Thank you. I got Ethan and Cassidy also. In the meantime, write your question. That'd be great. Do I have Isaac? And I have? Yeah, I got Inessa. Isaac. Do I have Anton and Devante? Do I have Alicia? Isaac is here. Thank you, Isaac. Yeah, I got Timothy P. I got you already. You're all set. Devante or Anton? And there's Ali. Thank you, Ali. Good. How will quarter test work? They won't at all. For third quarter, I'm going to be giving you just assignments that I will have you do, and they will encapsulate your third quarter grade. But I don't think I'm going to give you a third quarter grade per se. So I'll give you a final grade fourth quarter for the whole semester. I'm hoping I can get to you a test in the fourth quarter that will be back at school, but I don't know that, Alessia. Good. And Amelie is here. Thank you, Amelie. Let me see anybody else I'm missing. And Liam is here. Good. Exactly. So math and English and German will have more. That'll be the test you'll have. Good. I'm going to go ahead and start up for the day with you. I think that's most everybody. Thank you for joining me. And if you got any other questions, you can ask me. Julius is finally here. Thank you, Julius. Good. I'll check you in a little bit. Today we need to finish up with bomb making. So our goal is to talk about how the A team, using uranium, finished its bomb for World War II, and then talk about the B team today. Okay? And if we can finish those up, we'll also talk about a nuclear power plant and how those are used to make energy. Those are our goals for this hour. Okay, let's see if we got any other questions first. Yeah, you'll go to school for those tests, as far as I know, Alessandra. I think that's correct. And if we come back, will it be a hybrid or regular, Alessia? I have no idea. We'll find out. We'll find out together. As soon as I know, I'll let you know. Okay, but I don't think you guys are going back right away. Next week, the 11 and 12D will go back to school. This week, this week 12A is going back. So it's a slow process. We'll see what happens, right? It's my first time through a pandemic, yours too. So we'll see how it goes. Okay, let's see where we left off. So according to my notes, I'm going to look one more time. Yeah, we need to draw the bomb that the A team did. Remember, there were two teams, an A and a B team, and we're talking about World War II, and it was called the Project. Can somebody type in, what was the name? The Project. So I'm going to call this the Team A bomb. The Project. Jack knew it. Thank you, Jack. Leo and Zach as well. Manhattan. Reminder, of course, it didn't happen in Manhattan, but in New Mexico, out in the southwest of the U.S. Oh, everybody knew that. Thank you. Look at that. Charlotte knew that. Isabella, Corsin, thank you for participating. And Isaiah, several others as well. Nice. Okay, let's draw the A-team bomb. You ready? I'm going to change to blue here. I hope it works a little better today. Essentially, what they made was used a cannon barrel. So I want you to think of a long tube like this, but of course much, much, much bigger, like this wide, okay? Like this wide. So big, big tube. So in this cannon barrel, and we're going to look at the side view. By the way, this bomb is called the Thin Man. And they had some uranium here and here. Do you remember which isotope that was? Which isotope? You can look back in your notes and find me. This is U what? Which type of uranium was this? I'll write it up above. Uranium. What kind? Thank you. 230. Well, the second is right. Cassie, I think it's 235. Remember, 238 was the stuff that's found all over the place. That's in nature. But the stuff that's more rare that they had to like sift out, as it were, with a centrifuge was the U-235. So everybody write that, 235, 235. So they had two samples of this U-235, here and here. We're probably talking about 5 to 10 pounds of uranium, not a lot. So let's say about let's call it 5 kilograms. U-235. You can look up the exact amount on the internet, but it's not a lot, okay? Then on the outside of that, you ready? Outside of that, they had packages of more contemporary or more traditional explosives called TNT. I'm sure you've heard of that. Like the old bad rock and roll song, TNT. Commonly found in dynamite. All right, let me extend this barrel a little further. So again, this is like a tube, okay? Can you picture a tube? And in the tube, these two, and then these two. So how did the bomb work? Ah, Anton is here. Okay, thank you for reporting in. Glad you're here with us, Anton. I'll cross you out here. So you are with me. That's good. Anton. So how did this bomb explode, folks? What do you think they did? How do you think it worked? Hint, how did they reach critical mass with this bomb? Why do they have it in two parts like this? Seems kind of weird. Let's see what Leo says. They triggered the TNT and caused uranium to collide. Good. Okay. A chain reaction? Not to start off with, Jack. So let's look at what Leo said. So they blew the TNT, and then the TNT actually forced the uranium samples to collide together like this. And once the uranium samples collided in the center, oh, and to make it even more obvious, they had another chemical in the center, which was a source of neutrons. So I'm going to write here neutron source. You remember? Remember how the neutrons are bullets that split the atoms? So there's another source of neutrons in the middle, just to make it really obvious. But of course, the deal is just what Corsine said, and no, not Corsine, Leo said. And so the TNT was detonated, is the word to make it explode, detonated. And as Leo correctly guessed, this forced the U-235 samples to push together. This forced U-235 samples together. So there, at center, once they hit together, they reached and exploded. All right, this is a term from last time. Let's see who's got it. Let me read it off again to give everybody a chance, okay? So the TNT was detonated. This forced the U-235 samples together. There, at the center, the U-235 samples reached and exploded. What did they reach? Oh, look at that. I got Summit already there. Hey, nice. Jack is on the stick. Jack, Paul, Leo, Ethan, and a host of others. Holy moly, I can't even keep up. Can't keep up. Look at that. Everybody, thank you. Ayala, Kai, Isaac, Isaiah, Ingrid, everybody. Thank you. Thank you. Sorry I didn't call everybody's name, but I got most of you there. Nice. Critical mass is indeed correct. Remember, critical mass means the neutrons can't escape very well, so they keep splitting, and that causes the chain reaction. So then the chain reaction happens, Jack, during the explosion. Critical mass and exploded. Yeah? Okay. So this bomb, this type of bomb, this was dropped on the Japanese city of Nagasaki. Nagasaki. And killed tens of thousands of people. So it was, alas, successful. I won't go into the politics of it, but it killed an awful lot of people. and we'll talk about the effects of the radiation on the body another day. All right. But just to let you know, these are out here, and we have lots of these bombs in the US, in the UK, in Russia, um, India, Israel, Egypt. Lots of countries have these bombs. They are very devastating. And look how little fuel you need, right? Instead of U-235, if I used only TNT, I would need tons of TNT. So there's a lot of energy in fission. So this is a fission bomb, okay? Fission bomb. Another way to say it is it's an atomic bomb. So I'll write atomic or fission bomb. Right. And we're talking 1945, right? During World War II. Right at the end of World War II. Alicia's here. Thank you, Alicia. Or thank you, Alexander, for telling me this. I know sometimes students cannot necessarily tell me that they're there. So let me mark Alicia as being there. Good. Okay, got it. Isn't nuclear bombs a subtype of atomic bombs? I don't know. I think the two words are really used interchangeably, Alessia. What affects the time it takes for the TNT to explode? Okay, so what they do is they drop the bomb from the plane, and the bomb is falling, and the plane, of course, flies away. And there's timers. We'll put those on the other bomb. They're called detonators and electronic timers. And after a couple minutes, they went off, and the bomb exploded in the air and rained down on the poor people below. Okay. Once the TNT was ignited, Alessia, it is very quick to make this critical mass, okay? Within a second, okay? It doesn't take long to reach critical mass once I ignite the TNT on the two sides. So just like that, the bomb then explodes. Good. Any other questions before we change to the B team? Any other questions about this drawing or this type of bomb? So there's lots and lots of this sort of bomb in the world, alas. In fact, they're even bigger today, so they're even more explosive. Okay, now let's go ahead to the other team. Now, I'm calling an A and B team. I don't think they actually were called that. They just was a uranium team. And what fuel did the B team use? What fuel was in the B team atomic bomb? And it looks like I might have a question as well. Are there substances that take longer to reach critical mass? It's more like the other way around, Alessia. Most things will not reach critical mass at all. The two we know about are, thank you, everybody. Good. Beautiful. Hannah got that. Ayala, Leo, Kai, Ethan, Aaron, and it's plutonium. Yeah, plutonium. So there's a lot of things, Alessia, that really don't reach critical mass. And I don't know, even if it's a big atom, if it reaches critical mass, even if we had a lot of it. I don't know what's possible. So I think there's only so many big metals, maybe only two, I don't know, uranium and plutonium, that do reach critical mass and can be used to make a bomb. I don't know of other things that do. Thanks, everybody, for participating there. Paul had it, Isabella, Jack, Corey. Good. So the B team, plutonium. Okay, here was the problem here. Remember, A team had some problems as well. The problem with plutonium is plutonium reaches critical mass too easily. Too easily. They tried to put the plutonium in a canister like this with a chunk at each end, and they found that by the time they were trying to transport it, it had already reached critical mass. So it was very dangerous. Actually, I don't even know if they did that. They may have just done the modeling and found out that they can't do the same design with plutonium. So it reached critical mass too easily, so they did an entirely different design. So the solution looked like this. You ready? Here's the bomb. Draw yourself a big circle. It has think of it being like a sphere, okay? I know I can only draw a circle on the backboard, but it's a sphere. And it's a hollow sphere. We'll see why that is. So the outer sphere, ready? Think of it like a tennis ball. This outer part had lots and lots of TNT. All around it. Again, think of it being like a sphere, a hollow sphere of TNT. Then, inside of this, in pieces, they had an inner sphere of plutonium. And this is hollow, okay? So there's nothing in here. All right, they made it hollow because that kept the plutonium from each other more, and it didn't then reach critical mass until they wanted it to. Okay, then here's the tricky part. They had to have detonators. I'm going to put those as little tick marks, but they were all around the outside of the TNT. And the detonators to be honest, this was another problem they had, is to make all the detonators go off to start the detonation of the bomb all at the same millisecond. Okay, they had to have like an Italian detonator expert to rig up the electronics for this. So I'll say all go same time. Okay, so can you type in now? How do you think this bomb works? They dropped this, and how did this bomb reach critical mass? Can you type in a little guess for me? How did this bomb reach critical mass? What did they do? And while you're thinking and writing, I'm going to blow my nose. I'm guessing there's quite a lag because I don't see any answers yet. Let's see if they all come at once. How did they blow up this one? Anton says they collide into each other. Well, what are they, Anton? I need a little bit more. Neurons? No. And neutrons? They didn't have any extra neutrons. They didn't need that for plutonium. Aslan said the PU all collided in the middle. Aslan, there you go. Let's see who else got it. It's all colliding in the middle. They press a button which detonates the TNT, makes all of the PU collide, right, Alessandra? Zach, the TNT pushes the PU into the middle. Yes, Zach, exactly. Inessa, TNT destroys the shell and allows the PU to collide with each other in the middle, right, in the middle. Yeah, pushes the PU together. Yes, Ayala, that's correct. And it's not about energy. It's just pushing the fuel into the middle, Aaron, pushing the fuel. It looks like Leo got it as well. Good. Thank you, everybody. Yeah, we got it. Let's draw that. You ready? Sorry if I didn't get to everybody, but you're all thinking good. I like it. So boom, 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 boom. And again, think of a tennis ball like this that collapses. So think of a 3D hollow tennis ball, but a lot bigger. Okay. It was like this big. Okay. So it was big. The name of this bomb, well, let's write that over the side. So TNT caused the PU shell, we're going to call it, to get pushed together. Here's the scientific word for getting pushed together. It's called imploding. Isn't that a great word? Implode. It's a bad thing, but it's kind of a great word. So implode, that's the PU shell. Okay, then the plutonium then reached critical mass. I'm going to abbreviate that now, crit mass, and exploded. So first there was an implosion, then there was an explosion when we reached critical mass. Okay? Pretty wild, huh? This bomb is called the Fat Boy. And a bomb like this type was used on the Japanese city Hiroshima. At the same time, well, a few days later, it was 1945 still. And it was, alas, also successful, killed tens of thousands of people. And we'll learn again at a later time about the effects of radiation on the human body. So both of these bombs were used once. That's the only time they were used on people, was during World War II by the United States. So that having been said, I will just tell you that lots and lots of countries have both bomb types now, and other bombs as well that we'll talk about another day. Let's see if you have some questions. Yeah, in the middle. That's right. Exactly. That's where they were pushed together. Right. Yes, Allie. All right. Okay. It was called Fat Man. Exactly, Jack. Right. So that was, well, I think the other one, if I remember my notes right, it was Thin Man and Fat Boy. But you know what, Jack? You can Google it and see if I have the wrong name. So either Fat Man or Fat Boy. But the important thing for me is I want you to know how this thing actually worked, the physics of it. Fat Man and Little Boy. Thank you, Aslan. He's looked it up. Okay, so I stand corrected. If that's what it is in the internet, Fat Man and Little Boy. So let's change that to Little. No, this would be Fat Man. This one's the Fat Man. Okay, you can change your notes, the other one to Little Boy. Good, thanks for that. Corrections, always in order. Let's see if you have. Ethan has a good question. Because the PU was fragile, did it often explode before it reached critical mass? When they were trying to build it, they did have a tough time at first figuring out how to do this because they calculated, Ethan, that it would reach critical mass way too soon if they tried the other bomb type, the cannon barrel. So for this one, what was your question again? Yeah, the main problem they had was this outer thing. I got to tell you, the outer part of here was metal. So we could put metal on the outside of this, okay? This is metal. And what they spent a lot of time doing, Ethan, is blowing up metal spheres out in the desert, big ones like this big, okay, and try to make them implode perfectly. And a lot of times the problem was, Ethan, they did not implode very well. I know it sounds silly, but you needed to go from all sides all at once. And that's where this detonator expert guy came in handy to make all of them to the millisecond collapse and push in and detonate at the same moment once they blew the TNT. So they tried it often without plutonium, but with TNT out in the desert. See if I got any other questions from you. How much fuel did you need? Okay, again, I want to say it was like in the order of like a few kilograms. Let's say like 5 kilograms. Somebody can look that up too. Google it and prove me wrong. See if it's 10 pounds or 5 kilograms, something like that. It's not a lot. It's not a lot. And Ali says, didn't they ruin an island or something? What they did, Ali, is after World War II, they tested bigger bombs, the United States mainly, but also Russia, at remote sites and on some of the islands in the Pacific Ocean, including Atoll and Bikini Atoll. It's a small island, and they blew even bigger bombs. We'll study some of those in another day. So they did a lot of nuclear testing on these Pacific islands, and they did destroy some islands. Yes, they did. And the Soviet Union did a lot out in their deserts, and they did a lot underground as well, which had its own problems. Thank you, Aaron. 4.67 kilograms. Hey, so about 5 kilograms. For once, I remembered correctly. Thank you. And Leo has another 6.4 kilograms. Okay, so I'm sort of there with it. What was Tsar bombs? I don't quite get your question there, Aslan. Yeah. Okay. So, yeah, and a lot of people died exactly with both the bombs. Yeah, and Russia used some of their deserts to detonate them. Yeah, there's a neutron bomb which operates a different way. I don't know if one has ever been tested, Anton, and apparently a neutron bomb does not destroy buildings as much as it destroys the people, which is pretty awful as well. And I don't really know how a neutron bomb works. If you want to find that out and mail it to me, that'd be cool. But that's not something that's really in our curriculum, but it's interesting. There's another bomb called a hydrogen bomb. We'll learn how that works another day. Good. Any other bomb questions from you? Yeah, hydrogen bombs. We're going to talk about that another day, Alessia, because that has how do they work? We're going to find out. But I don't want to do it now because it's a very different process than this type of bomb. Okay, last bomb questions before I erase it. We need to start something a little less explosive. Okay, here we go. Thanks for your interest in bombs. Please don't make one at home or at the office. It does not make a very nice gift. Okay, so here we go. We're going to talk about a more positive use of fission, and it's called a nuclear power plant. Nuclear power plant, okay? And essentially what these do is they they use something that is a controlled fission, not out of control, like a chain reaction, not like a critical mass, but they use controlled fission. To give off heat. So I'll say to heat water into steam. The steam runs steam turbines to make what? Okay, let me read that off and then we'll see if you have some, okay. Um, Not sure what you mean, Alexandra. Okay. Right, Chernobyl. Okay, right. Yeah. Yeah, we're going to talk later on about Chernobyl and some other accidents that happened around the world. Okay. Including Fukushima and 3 Mile Island and so on. Okay. In different places around the world. For now, let's fill in the blank. Here we go. So, nuclear power plant, they use controlled fission, pardon me, to heat water into steam. The steam runs steam turbines to make what? What's the goal here? What sort of energy? Energy is not really enough. What sort of energy? What are we making? Because we're going to need this later in our course when we study electromagnetic effects. What kind of energy? Yeah, so energy is a little vague. There's lots of types of energy. One person got it. Alessandra has it. Electricity. Electricity. Okay? Especially in our modern world with computers and we're charging stuff up all the time, we need more and more and more electricity. That's a problem. Our smartphones are problems. Our computers are problems. They eat a lot of electricity. One way to get that electricity is nuclear power. I'm going to try and give you the facts about it, and you are going to have to decide whether it's worth the risk or not. There are some disadvantages with nuclear power and some risks. But you know what? There's some big advantages with nuclear power as well. So, okay. All right. Okay. Electricity, right? Exactly. So we need like lots and lots of kilowatts of power. All right. Let's see how this works. Okay, I got just a few minutes. We can start to make the skeleton of it so we see what's going on. Okay. All right, I got to erase this. So I hope you got it. Yes, I can charge a phone with a battery, but guess what I got to do? I got to charge the battery sometime with electricity. So it's hard to get around it, Alessia. You got to have electricity to charge our accus, to charge our batteries, to charge ultimately everything. Even our cars probably rather soon. Okay, you guys will definitely be driving electric cars someday or hydrogen cars, but we'll get into that another day. Okay, so here we go. Let's do this. You know what I really need is yellow. I don't have yellow. If you have yellow, could you use yellow instead of red? So if you have yellow, we're going to draw some of these things, okay? We're going to draw a bunch of these guys. They should be yellow because that's the color of the fuel. The fuel, not surprisingly, the fuel is uranium-235. So these are called fuel rods. They're like this big, okay, and they're long. And they're not just like this, they're in 3-dimensional. So think of lots of like a forest of them, okay? So we got fuel rods of uranium-235. Wasn't that the same stuff in the the Little Man bomb, or now I forget the name again. The first bomb, the A-team bomb. Yes, it was. It was the same stuff, but not as enriched. It's a lower percentage of it can be used to make nuclear power. All right, let's see what we got. I got an argument going on. Okay, why don't we put that on hold? So Jack and Leo, you can maybe text each other, but probably don't need to do that here. Thank you. Okay, all right. Okay, so these are my fuel rods. And essentially, it's not quite perfect, but I'm going to show you sitting, I'm going to have them sitting in water. All right. It's not quite how it looks, but we're going to have that for this particular water. And we're going to have some piping here come out of the water. And we'll go and finish that maybe next time. The other thing we have here, and by the way, what happens is what? These guys are all made of U-238. So the neutrons can do what? The neutrons can fly across here. Can you make some neutrons flying around? Boo, boo. So they go from one rod to the other, the neutrons. And I'll say neutrons flying. Remember, neutrons are bullets, right? Neutrons splitting atoms. So draw some of those moving back and forth. That's the actual process. And of course, it's heating up the water. So the water, and I'm going to write this way, we're going, leaving here is going to be hot water / steam. The water gets very hot indeed. And we'll see where that goes probably next time because we're quickly running out of time. Now we need to build up above some other rods. These are suspended from the ceiling. And these can be moved. They like fit in between here, okay? So they fit in between the other rods. So they're all kind of up here. And these guys can go up or down. So think of it being attached to the ceiling up here, okay? So this thing can go up or down, and they are called the control rods. They are super important. Super important. In between the rods, exactly. Yeah. Yeah. So the neutrons are flying in between the fuel rods, and then these control rods are up here. Okay, I'm going to have to do the next later in the week when I see you. I'll decide today when that is. I got to look on my schedule. And we're going to pick it up right there. So we'll next time talk more about what's going on with the control rods, and we'll draw the rest of the nuclear power plant. Okay? So I'll try and draw some of this again next time so you have it on there. Okay? So that's about it for today. It's a bit for it. Was there some sort of alternate power source, or was that it? No, that's it, Ethan. I mean, that's one way to get electricity. It's one way to do a nuclear power plant, and it's really it's the way most of them are designed. There's other power plants that burn coal, like in Berlin, but this one, a lot of these are in France. This uses nuclear fission. Okay, good. We'll see you next time. Bye until then. Stay healthy.